Hello everyone. So in last lecture I started game theory. In game theory I taught Minimax Maximin principle to find saddle point. Now in this lecture we will see another method to find saddle point. This is principle of dominance. So strategies and methods of game theory, and there are two strategies. First is pure strategy and second is mixed strategy. So if the game is with saddle point, then this is considered as pure strategy, and if the game is without saddle point, then this is considered as mixed strategy. And to find this saddle point we have two methods. First is Minimax Maximin principle and second is principle of dominance. So we have already covered this Minimax Maximin principle, and in previous question we got saddle point using principle of Minimax and Maximin. This one, as this location is same, so this is saddle point and this is also known as value of game. Now there is another method to find this value of game or saddle point. This method is known as principle of dominance, and the utility of principle of dominance is two. Just first part is to get saddle point, and second part is to reduce the size of payoff matrix. Why we will reduce the size of payoff matrix? Because we need to apply algebraic method or graphical method in case when we don't have this saddle point. So today we will see principle of dominance. So we have this same question. So first we will focus only on this concept, elimination of small row and big column. In short, we can write RSCB. This means row small, column big. Now we will search either row or column. If we are considering a row, so we will search smallest row. Smallest row means all the elements of this row must be lesser or equal in comparison of any other row, or we can compare with average of other rows also. Just like suppose we want to compare this first row, we want to eliminate this first row. So first row, all elements must be smaller than any other row's element, respective element. Just like this 3, this first 3 is not less than -1, so we will not compare with this second row. We will compare this first row with third one. So this 3 is lesser than 16, satisfied this condition, row is small. So this 3 is lesser than this 16, and this -1 is lesser than this 8, this 4 is lesser than this 6, this 6 is lesser than 14, and this 7 is less than 12. In this case, all the elements of first row, this means this first row, are smaller than all the respective elements of row third. So we can say row third eliminates or dominates row first. Row third dominates row first. Hence the reduced payoff matrix is, we will remove this first row, so in new step we will remove this first row. This first row, now the remaining elements and rows and columns are these. Now again we will try either row or column. So you can apply from column, you can apply from rows, or you can again and again row, again and column. So now I am trying to eliminate one row once again. So I am comparing this row, this second row with this third one. So this minus 1 is lesser than 16. This 8 equals to 8. This 2 is less than 6. This 4 is less than 14. This 12 is equal to 12. This means condition that all the elements of row must be lesser or equal in comparison of all the respective elements of any other row. So this is lesser, lesser, equal, lesser, lesser, and this is equal. So again we can eliminate this second row. So we will write row third dominates row second. Hence the reduced payoff matrix is, so now we will eliminate this second one also. So the reduced payoff matrix is now this one. Okay, so now we have two rows. Again we can compare rows, but now we will eliminate some columns because only two rows are left. So now we will try to eliminate column, and column must be greater in comparison of any other column. So we can compare column like this first column we can compare, and all numbers must be greater. So this 16 is greater than 8, right? This 1 is not greater than 11. So we can't eliminate this first column in comparison of second one. Now we will try this first column with third one. So this 16 is greater than 6. This 1 is greater than minus 4. This means in comparison of third, we can eliminate this first one. So we will write this column third dominates, this column third dominates column first. So the reduced payoff matrix means we will eliminate this first column. So this is reduced payoff matrix. Again we will try to eliminate more columns. So now again big column we can compare this one, second one, with respect to third. So 8 is greater than 6 and this 11 is greater than minus 4. So we can eliminate this second also. So now again, so now this second is removed. So the reduced payoff matrix is this one, and in this case this third eliminates, this C third dominate column second. So reduced payoff matrix is this. Now again we will try to eliminate more columns. So this 14 of fourth column is greater than 6. This 2 is greater than minus 4. So now in next we will eliminate this fourth column. So on eliminating this, the reduced payoff matrix is, we will eliminate this fourth column. So you will see this table. Now this matrix is reduced in form of 2 by 2 as there are two rows to two columns. So we can apply algebraic method in this situation as the size of this matrix is 2 by 2. But now in this case we will try to eliminate more rows and more columns because we can get directly saddle point by eliminating row and columns. So again we are trying to eliminate this fifth one. So this 12 is greater than 6 and this 1 is greater than minus 4. So you can eliminate this last column also. So on elimination of last one, you will see this situation. This is the reduced table, and again now you have only 2 rows. So in 2 rows case, you can eliminate 1 row, and row must be smaller. So there are 2 rows, first is this 3rd row and this is 4th row. So you will see in this 4th row, this is -4, and this -4 is lesser than 6. So this means you can eliminate this -4 also. So on doing this task, you will see there is only element, this is 6. So now you have only one element, 6. So as only one element is left, so this 6 is considered as saddle point. If only one element left, then this is considered as saddle point, or we can say this as value of game. So this is the methodology of principle of dominance. Always we will remove a small row and big column. So I hope you understand this concept. In next lecture, we will see case of algebraic method. So please like this video and subscribe my channel Ganit Coach. Have a nice day. Thank you.